If the eye then looks at another colour, say yellow, the colour actually registered will be a green, the combination of the yellow and the induced blue. And here we see the effects of putting threads or fine lines of the complementaries red and green next to one another. From a distance, the colours, the bright colours, appear a brown. So there we are. And as you go further away, they blur. And what you actually see in this particular example is brown. The influence of this could be seen in the work of painters like Delacroix. And as we know, he was very, very concerned with the effects of colour, but not in a systematic way. Following him, the Impressionist painters, as we see in this example. And here we see an orange-blue contrast from the orange of the boat to the blue. Following him, Seurat. Oh, that's a better example of that. There we are. Seurat observed that simultaneous contrast is most marked along the boundary between two complementary colours or two tones of the same colour, an effect he made use of many times, as here in the seated figure of the bather. There we are. And the pale figure is made to stand out very much more by the intensification of the blue in the water and the pale peachy flesh here, and here blue flesh, blue shadow, and he's done a white intensification, a halo in the water here. Research done by Thomas Young at the beginning of the 19th century and developed by Hermann von Helmholtz had revealed that white light consisted of three different primary colours: an orange-red, a green, and a blue-violet. These graphs are the 19th century versions. They're actually from Helmholtz's work. And in fact, the yellow-green peak of the response is not as it really is. We actually know it's slightly different. These are the colours to which the cones in the retina of the human eye respond. If light of the same of these colours is mixed in the correct proportions, white light is obtained. Yellow light results from mixing red light and green light. And this is additive mixing here. When pigments and dyestuffs are combined, however, the mixing is subtractive. A yellow pigment appears yellow because it absorbs light from the blue and violet regions of the spectrum, reflecting the rest. Ideally, a mixture of red, yellow, and blue, the three subtractive primaries, should therefore yield black, as light of all colours is absorbed. In practice, it gives a greyish colour. Mixing a primary, red, with its complementary secondary colour, green, will, as we have seen, also give a muted greyish colour. In our example, it was actually brownish. And in fact, the true subtractive primaries are not red, yellow, and blue as convention would have it, but a bluish red, magenta, yellow, and a greenish blue, cyan. So magenta, cyan, yellow. And these are the complementary colours to the three additive primaries of coloured light: blue, violet, green, and red. And you can see magenta is the complementary of the green. So, how were painters to represent the effects of light on the canvas? The clearest and most relevant explanations were given in Ogden Rood's Modern Chromatics, with applications to art and industry, which was published in New York in 1879 and translated into French in 1881. This was read by Seurat and, in Italy, by some of the divisionist painters, Vittorio Grubizzi di Dragon, Angelo Morbelli, Gaetano Previati, Giuseppe Pellezza, Giovanni Segantini, and others. Rood carried out colour matching experiments, many based on spinning discs of paper, painted in different colours, others using coloured glass filters under different lighting conditions. From these and a series of equations he derived from them, he constructed an accurate diagram of contrasting colours, from which it can be seen that, for example, vermilion is complementary to a greenish blue. So there we are. There's vermilion. And over here, we have a greenish blue, which is close to cyan, I suppose. And emerald green is complementary to purplish red. Emerald green, red purple. This slide also shows a plate from Chevreuil's work in which he demonstrates the simultaneous contrast of tones of the same colour. I mentioned this earlier. It's here. In this case, it's different tones of Prussian blue. The work also showed, going back to Rood now, the work also showed that a purple colour, for example, obtained on the palette by mixing equal quantities of red and blue was less luminous, in other words, blacker, than a purple obtained from the same equal quantities of red and blue, but mixed by rotation of a spinning disc of coloured papers suitably lit. One of Rood's most influential statements, referring to earlier work, described another method of mixing coloured light. And I'll summarise part of this rather long quotation. We refer to the custom of placing a quantity of small dots of two colours very near each other and allowing them to be blended by the eye placed at the proper distance. Millet, who originally published the idea in 1839, traced fine lines of colour parallel to each other, the tints being alternated. The results obtained in this way are true mixtures of coloured light. This method is almost the only practical one at the disposal of the artist, whereby he can actually mix, not pigments, but masses of coloured light. And in this, we can see the genesis of the dotted technique of Seurat, seen here in his painting of Gravelines, and his followers. I'll show you a detail of this. This is a detail of the boats. In fact, it's two details. There, and then this is it larger, and you can see there's the pink, yellow, and the blue. A bit of green there. So he's worked using this method to give him the colour of the blue. If I go back again, there we are.